A metal disc is made to spin at 20 revolution per second. So there is one metal disc. एक metal disc है आपके पास में. So we considering this is a metallic disc. So this is metallic disc is a spin. It means that spins at 20 revolution per second. 20 revolution per second से spin हो रही है about an axis passing through its center and perpendicular to its. It means that so it is a spin like about an axis passing through its center. So this is your axis of rotation. So this is the axis of rotation for this metallic disc, and it is rotating about an axis and passing through its center. Yeah, it is a spin about an axis passing through its center, and it is a spin at 20 revolution per second. So it means that it is a frequency. So F is equals to 20 revolution per second. So this is 20 revolution per second. So revolution per second is a silent of frequency. There is no need to change the frequency that is in RPS. It is already in RPS, so we don't have to convert in SI system. So it is already in SI system. About an axis passing through its center and normal to its plane. The disc of this has a radius of 30 centimeters. So it has a radius. So R is equals to, so this is 30 centimeters. So it means R is equals to 30 into 10 to the power. This is minus 2 meter. And a spin in a uniform magnetic field of 0.20 Tesla. So that is B is equals to 0.20 Tesla. So this is your magnetic field which is parallel to the axis of rotation. That means this is magnetic field which is parallel to the axis of rotation. So it means that so these are this parallel. So this is parallel to the axis of rotation. Clear? So this is magnetic field. ये आपकी magnetic field है यहाँ. So which is parallel to the axis of rotation. Calculate. Now see, calculate first. So what we have to calculate? The area swept out per second. मतलब मेरे को area swept out करना है, area निकालना है मेरे को per second के लिए by the radius of the disc. It means that when this metallic disc spin, जब ये spin होगी तब area कितना swept out होगा per second में, एक सेकंड में कितना एरिया स्वेप्ट आउट हो रहा है बाय द रेडियस ऑफ द डिस्क. रेडियस के वजह से एरिया कितना स्वेप्ट आउट हो रहा है पर सेकंड के लिए, दैट्स वी हैव टू कैलकुलेट इन फर्स्ट एंड देन सेकंड इन द फ्लक्स कट पर सेकंड. फ्लक्स कट्स पर सेकंड, द मीनिंग ऑफ फ्लक्स, there is these are this magnetic line of forces, and when it is spins, so this magnetic line of forces is cut by the spins of metallic disc. जब ये मेटालिक डिस्क कंटिन्यूअस स्पिन होते रहेगी, सो देयर इज मैग्नेटिक लाइन ऑफ फोर्सेस एंड देयर इज कंटिन्यूअसली कटिंग ऑफ मैग्नेटिक लाइन ऑफ फोर्सेस, एंड व्हेन देयर इज कटिंग ऑफ मैग्नेटिक लाइन ऑफ फोर्सेस इट considered as a magnetic flux. So that is uniform magnetic field. When it is cut, so it is converted into a change in the magnetic field. So the flux cut per second by the radius of this disc. Again we have to calculate the magnetic flux by the radius of the disc. Then again induced EMF in the disc. EMF मतलब तीन वैल्यूज मेरे को निकालना है. एरिया स्वेप्ट आउट पर सेकंड, देन फ्लक्स कट पर सेकंड, एंड अगेन द EMF is induced in this disc. Clear? So now first, so area swept out per second. So what is the area swept out per second? So you have, if I'm taking area swept out per second, area swept out per second is equals to area of disc, area of metallic disc and multiplied by its frequency. By its frequency we are taken because यहाँ हम लोग को frequency दी है, because यहाँ आप swept out per second लेंगे तो divided by time में हो जाएगा, 1/time it's a frequency. So it's a frequency of this disc. Clear? So area swept out per time per second. So this is area per second या area per time आप ले लेंगे. So area per time is equals to area of the disc. This is pi r square multiplied by f, and this is frequency. Pi r square multiplied by frequency. So again area divided by time. So this is area swept out per second. So we can consider this area swept out per second. आप इसमें इसको second में ले लो. So again this is pi r square. So this is 3.14 multiplied by r square, and we have the value of r. This is 30 into 10 to the power minus 2 square multiplied by frequency, and this is your 20. Clear? So after solving this value, so we get the area swept out per second. So area sweeps out per second, area sweeps out per second is equals to your 5 point, after solving this terms, 5.656 meter square. Clear? So this is area sweeps out per second. So this is your value for first term. So ये आपका पहला टर्म हो गया, आपको 3 टर्म सॉल्व करानी है. So this is your first term. So what is your second term? Second term is your the flux cut per second. Again. So now, so what we have to calculate in second terms? The flux cut per second. It means that if I am taking second portion, that is a flux cut per second. So it is represented by its d phi divided by dt. Flux cut flux per second. So again this phi we know that phi is equals to b into a. So again flux cutted per second. So it is again b into a. Again this is b into a. So this is your b is what? 0.20 into a. So a is again pi r square. पर सेकेंड के लिए लेना है. सो डिवाइडेड बाय 1 सेकेंड. क्लियर? सो आफ्टर सॉल्विंग दिस एग्जाम कंप्लीट टर्म, सो दिस इज फ्लक्स कट पर सेकेंड and it is represented by d phi by dt. So again if after solving this complete term, so we get that is 1.131 and this is Weber per second. So this is Weber per second. So this is a flux cut per second. Clear? And the third term is, we have to calculate the third term. And what is our third term? So see here, what is our third term? The induced EMF in the disc. If I am taking the magnitude of induced EMF in the disc, so this is formulas according to Faraday's second law of electromagnetic induction, d phi by dt. Clear? And again we have the equation for d phi by dt. It's 1.313 Weber per second. So again we can put directly here. So this is 1.131. This is electron. So this is a magnitude of induced EMF. So this is volt. So this is your second question. It's a very simple question. Okay. Thank you.